Next, I have the pleasure of introducing David Etim. Mr. Etim is the Federal Program Manager for the Verification and Validation Subprogram in the National Nuclear Security Administration's Office of Advanced Simulation and Computing and Institutional Research and Development. Mr. Etim oversees the application of critical skills and tools at the NNSA laboratories needed to ensure models and codes predict physical behavior and produce accurate methods and assessments. He also manages the Predictive Science Academic Alliance program, overseeing universities' participation in research needed to further predictive science and effective extreme scale computing. Mr. Etim is a federal point of contact for the NNSA academic programs, the DOE Computational Science Graduate Fellowship, the ASC Advanced Machine Learning Initiative, and the ASC Large Scale Calculations Initiative. He has a master's degree in computer science and engineering from the University of Connecticut and a bachelor's degree in computer science with a minor in applied mathematics from North Carolina Agricultural and Technical State University. Welcome, David.
Hello, everyone. Is my audio okay? Can you all hear me?
Yes.
Okay. Yeah, thank you very much. So thank you, David, for that introduction. And I'd first like to just follow along Christine's comments and first of all, thank the Krell Institute for this invitation to give this welcome talk this morning, as well as I'd like to thank everyone in attendance, especially the new and current and outgoing CSGF fellows for their perseverance through this difficult year during the pandemic to complete research and to continue their requirements for the CSGF fellowship. As David mentioned, I am a federal program manager in the NNSA Office of Advanced Simulation and Computing. And today I'll just be giving an overview of what we do in ASC, as well as talk about some things as far as DOE and the National Nuclear Security Administration. Next slide, please. So to provide a bigger picture of the United States Department of Energy, just showing the overall organization chart here. So with NNSA, NNSA is sitting under the Office of the Undersecretary for Nuclear Security and NNSA. So specifically, my office, the Advanced Simulation and Computing Program Office, is in what we call NA10, which is the Office of NNSA Defense Programs. And as you'll see on this chart, you'll notice where Office of Science is sitting at, which is under what's called S4, the Office of the Undersecretary for Science and Engineering. And with that being said, you know, it's an honor to be able to have ASC continue to support the CSGF program in conjunction with funding support from the Office of Science. And as you can see, if you're not familiar with the overall bigger picture of DOE, it's there's a lot of resources in the department, and there are a plethora of offices in which help towards the bigger mission of the Department of Energy. Next slide, please. So here is just the chart for the National Nuclear Security Administration. So our acting Undersecretary for NNSA is Dr. Charles Ferdinand. And like as I mentioned, so the various programs, starting with defense programs at NNSA, in which ASC sits under, you'll see that NNSA is working towards mission needs in various areas, such as like nuclear nonproliferation, naval reactors, as well as collaborations and how NNSA works with external affairs, the general counsel, management, budget, and various other offices. And you'll see the connection. There is a connection with the NNSA laboratories, obviously with the Los Alamos, Sandia National Laboratories, and Lawrence Livermore, in which the science and technology and a lot of the research development is happening in that tri-lab community. But you'll see a conjunction with the field offices below, with Kansas City, Livermore, Los Alamos, Nevada, the production office, as well as Sandia and the Savannah River. So this organization chart is just a picture of how the nuclear security enterprise is kind of comprised, and how each of these offices and program offices are working together to fulfill security enterprise mission needs. Next slide, please. So also, another org chart here is what I'll talk about as far as our office, the Advanced Simulation and Computing program. So the ASC is, there's the simulation side of the house as well as the computing side. So myself, I manage the verification and validation subprogram, which is where the integrated codes and physics and engineering models connect to meet each other to help towards verifying and validating that the physics models, the codes, to help be deployed towards the needs of nuclear security, as well as the stockpile stewardship mission as well. And our director is Tuk Wong, and she heads the computational science and software environment subprogram, and Mike Lang is the facility operations and user support leader for that subprogram. So you also see a collaboration here with academic programs. So as David mentioned earlier, I'm the manager for the Predictive Science Academic Alliance Program and the point of contact, the NNSA point of contact for the CSGF fellowship as well. So in ASC, along with simulation and computing, there is the initiatives that we have, or the special purpose topics, and that includes activities in advanced machine learning, where it's the activities include certain projects that involve artificial intelligence, data science or data-centric computing, as well as machine learning projects. We also have the exascale computing initiative, the large-scale calculations initiative on production science, as well as quantum computing. So each of these initiatives really tie into not just the overall mission of ASC, but they tie into both the simulation and computing sides of the house. And there is a lot of connection as far as the activities that are done at the NNSA laboratories and just within just ASC overall, that tie into how we work in both sides of the house for our simulation and computing projects and the work that we're doing there. Next slide, please. All right, so ASC has three main objectives. So the first objective is the performance of predictive simulation, and that includes how we're delivering verified and validated physics and engineering codes to enable these simulations, as well as have the ability to make informed decisions or risk-informed decisions on the performance of nuclear weapons, the safety in that nuclear weapons performance, as well as reliability. So reliability in how we're conducting the simulations, the confidence that we can create in that modeling and making those decisions based on nuclear weapons performance. So also an objective is how we create our robust tools. So this involves the development of robust models, codes, computational techniques to support things like, the life extension programs, annual assessments. This is all towards supporting the stockpile stewardship needs, as well as the the current and future requirements involving that support. And we also are, working and working towards the objective of the balanced operational infrastructure. And this infrastructure includes the implementation of a balanced computing strategy of platform acquisition and operational infrastructure. And this infrastructure is significant because it's meeting the needs for production and advanced simulation capabilities through meeting, the certain requirements for the directed stockpile work program, as well as the stockpile stewardship program. But if there's a takeaway from what you learned from ASC is that the predictive science that is being conducted is that ASC is conducting is through the simulation, is through the people that are working on these tools in these environments every day, the computational platforms that are developed and maintained, as well as the simulation tools that are used in certification of the nuclear weapons stockpile. Next slide, please. So to dive in a little bit to the 10-year vision, and as well as some of the challenges that were the current challenges and things that we're working towards is just the 10-year vision and just at a high level. We want to focus on ensured, validated, and predictive capabilities to address, evolutions and changes that face the nuclear security enterprise. So this includes continuing science and integrated weapons codes development. This also includes our system deployments for high performance computing, next generation codes, and addressing changes to the hardware landscape, in collaboration with the software environment, as well as the modern computing facilities and efficient operational support, as well as adapting to next-gen technologies, future technologies to meet, future weapons missions. So, and also a big part of this 10-year vision is developing and maintaining a high skill and specialized workforce. And that's also part of one of our challenges too. We say challenge in the fact that this is something that we're continuing to work towards each year as far as attracting new talent. And there's several ways and different ways that we can be able to reach out to new members and new people like those in this program review that are currently in the CSGF to help us towards challenges like improving predictive capabilities, as well as how to do large scale calculations more efficiently, as well as working towards our challenges overall in computing technologies. Next slide, please. So this is just the overall program structure of ASC. I've touched on pretty much these sub-programs, but these are the 6 sub-programs within ASC that fit the overall program structure of ASC. And each of these sub-programs kind of work in various ways with each other to work towards the main objectives that I had explained earlier. Next slide, please. So ASC with there's a collaboration with the academic programs, the NNSA academic programs, and this basically is a collaboration to work towards certain goals that are, helping to provide a more diverse and skilled technical future to meet various needs regarding NNSA mission needs, assuring quality through different reviews and how we address challenges through our academic programs. So and also being able to have that creative input, and that means leveraging expertise in areas thinking outside of the overall mission goals. So the map here on the right just shows the different centers and the involvement that that NNSA academic programs and the programs involved, like the Predictive Science Academic Alliance program, for example, the centers that involved, as well as just the overall NNSA academia interaction that is continuing throughout the United States. Next slide, please. And so here's the program structure for the academic programs, and this is more so like just the point of contacts or the managers that are leading these programs, and with Sarah Nelson being the overall program leader for this initiative. And this is just to these are the people that are working towards being able to provide better solutions towards the collaboration that NNSA has with academia and the overall academic community, being able to do what's possible to help towards more innovative research and allow more support and highlighting of the collaborations that we have with the academic community. And that involves, programs like this one, like CSGF and other academic programs as well listed here. Next slide, please. And so in summary, just to kind of go back on what ASC is and how, we're in conjunction with how this is in effect with like the CSGF program. So ASC has, provides the necessary resources for simulation and computing capabilities for NNSA defense programs. And that includes being able to have the enablement for nuclear certification, as well as facing the different challenges and the future, the future technologies that are involved with an evolving computing landscape, as well as continuously improving to support new missions that may come our way. And also, and last but not least, this is one big thing big part of ASC, as far as how we want to be able to have a maintenance and retainment of a highly skilled workforce. And so it's exciting to see a new, the growth of, programs such as CSGF and other academic programs. And even it's exciting to see, I think a record number of 32 new CSGF fellows that were selected this year. So the workforce development, the initiative that we have towards that, and in conjunction with academic programs and other offices that are working towards having a more highly skilled workforce, is very important. And we believe that the work that we're doing within ASC, NNSA, and overall the overall Department of Energy is very substantial work, is very exciting work. And again, it's something that is very exciting to see, and how we can work better with the academic community and influence the workforce pipeline. So with that, I just want to say thank you, and I look forward to seeing the fellows talks during the week, and I'll take any questions at this time.